Welcome to the solutions to the Thermodynamics Problem Set, problems number 15 through 21. Question 15, a tile floor may feel uncomfortably cold to your bare feet, but a carpeted floor in an adjoining room at the same temperature feels warm. Why? The answer to this question is because the tile is a better conductor of heat than on your feet than the carpet. So to you, the tile feels colder because it conducts heat from your feet faster than the carpet, which conducts heat more slowly. So even though they might be the same temperature, the tile is going to feel colder because it's taking heat out of your foot faster than the carpet does. Question 16. Concrete has a higher specific heat than soil. Use this fact to explain, partially, why a city has higher average temperature than the surrounding countryside. And would you expect evening breezes to flow from the city to the country or from the country to the city? I've included a diagram here with this black area, the skyscrapers being the city, the blue being the sky, and the green being the countryside. Well, because concrete has a higher specific heat than soil, that means it's going to hold and absorb heat for a longer amount of time than the soil out here in the countryside. That means at night, it's going to be giving off its heat for a longer amount of time than the countryside. That heat will rise and create a convection current that comes out to the countryside and pushes the cool air back in towards the city on both sides here. So what you're being tested on in number 16 here is the concept of convection. Along with your understanding that specific heat means that it will take longer to absorb heat, but it also will hold that heat for a longer amount of time. A similar example of that was a few winters ago when I took my Coast Guard captain's license, and we talked about this phenomena of a land breeze versus a sea breeze. And it also has to do with the fact that water has a higher specific heat than soil does. So water would take longer to warm up during the day in the morning, and because of that, at dawn, the heat would rise from the land and create a convection current like this away from the water toward the land. And that is why at dawn it's called a sea breeze, because the breeze is coming in from the water. At night, the water is going to hold that heat longer, and therefore the heat will rise from the water and create a convection current, meaning at dusk we get a breeze from the land area. This is important to know if you're operating boats, especially sailboats. Okay? 17, you need to pick up a very hot cooking pot in your kitchen, and you have a pair of hot pads. Should you soak them in cold water or keep them dry in order to pick up the pot most comfortably? And explain. You want to keep them dry. This is because the air pockets in the pad conduct heat more slowly than the water would. Wet pads absorb some heat in warming up themselves, but the pot would still be hot and the water would quickly conduct and convect a lot of heat right up to you. In fact, if the pot was hot enough, it could create steam from the water, and you would end up with a steam burn. So you want to use a dry pot holder because the air pockets in that pad would conduct heat more slowly than the wet pad would. And if you've ever done this by mistake, you learned that mistake. On to number 18, and from here on out, the common theme to all these questions is the mechanical equivalent of heat. They like this connection between mechanics and heat, that you can create heat mechanically, and it's called the mechanical equivalent of heat. And all the problems from here on out have that common theme. 18, as part of an exercise routine, a 50-kilogram person climbs 10 meters using a vertical rope. How many food calories are expended in a single climb up the rope? First neat little part you learn here is the difference between a calorie and a food calorie. You notice that a food calorie has a capital C and a regular calorie has lowercase c. A food calorie is 1,000 calories, and then one food calorie is 4,184 joules. Note, by the way, how close to the specific heat of water that number is. And that's because a lot of the foods we eat do mostly have water in them. Not all, but most. Okay, so what we have here is that the change in gravitational potential energy, which would be 50 times 10 times 9.8, is transferred into heat. And so if you take the 4,900 joules and divide by the 4,184 joules, you would expend 1.2 food calories in climbing that rope. So not a lot, but 1.2 food calories. Number 19. A 70-kilogram Weight Watcher wishes to climb a mountain to work off the equivalent of a large piece of chocolate cake rated at 500 food calories. How high must a person climb? Well, this question is kind of the opposite of number 18. Here, what you're going to figure out is how many joules are in 500 food calories. So converting that using dimensional analysis, you get 2.09 times 10 to the 6 joules. And then you're going to use that to say that needs to be the change in gravitational potential energy, and set that equal to the person's mass times little g, 9.8, and solve for h. Calculating, you should get 2.85 times 10 to the third meters. Number 20, a 5-gram lead bullet traveling at 300 meters per second is stopped by a large tree. If half the kinetic energy of the bullet is transformed into internal energy and remains with the bullet, while the other half is transmitted to the tree, what is the increase in temperature of the bullet? Clearly, the first thing we need to do in this question is find out what the kinetic energy is, so we can calculate half the kinetic energy to know how much remains with the bullet in the form of heat. Using our kinetic energy formula, K equals 1/2 mv squared, we convert our 5 grams of lead into kilograms, 0.005, times 300 squared is 225 joules. We now need half that value. That's converted into heat, so 112.5 joules. And then we set that equal to a Q equals mc delta T, where that 112.5 joules equals the mass times the specific heat of lead, which we go and look up to be 128 joules per kilogram degrees Celsius. Solve for delta T, and that becomes our change in temperature of our lead bullet. You can see here that that lead does get incredibly hot if that were to be true. That change in temperature is 176 degrees Celsius. Lastly, number 21. The bottom of a copper kettle has a 10 centimeter radius and is 2 centimeters thick. The temperature of the outside surface is 102 degrees Celsius, and the water inside the kettle is boiling at 1 atmosphere of pressure. Find the rate at which energy is being transferred through the bottom of the kettle. Once again, another repeated theme here. They want us to find the rate of energy. And what you need to hear is power. You need to hear joules per second or watts. Okay, so first thing we need to do is find out our rate of heat transfer. This is kind of a one-time only problem. We'll see more of this, but this is the only question in the problem set that uses the rate of heat transfer equation. H equals Ka delta T over L. Substituting, you look up the K value for copper, which is 397. A is the area exposed, and that would be a circle. which is 10 centimeters, 0.1 meters. So pi r squared, pi times 0.10 squared. And the change in temperature is 2 degrees Celsius because it's the difference in temperature between the outside of the kettle at 102 and the inside of the kettle, which they told us was boiling at 1 atmosphere pressure, meaning that has to be happening at 100 degrees Celsius. So the change in temperature is 2 degrees Celsius. The L value is the distance, the thickness or distance the heat travels to get from one spot to the other. This is the 2 millimeters, which is 2 times 10 to the negative 3 meters. Go ahead and do your calculation, and you get a rate of heat transfer of 1.25 times 10 to the 4th joules per second, which would be 1.25 times 10 to the 4th watts. More to come on mechanical equivalent of energy of heat, mechanical equivalent of heat questions when we resume these problems in class tomorrow.